Most of the programmers can write the code, but very few actually understands what happens inside the memory. Today, we are not just learning data types, but we are visualizing them. If you ever been confused with primitive versus non-primitive data type, a stack versus heap, uh, or pass by value, then this video is for you. This video will permanently fix these issues. So welcome back to my YouTube channel Code with Dharamveer. Now let's get started here. Let's quickly begin with one of the program here in Eclipse and quickly go there and let's guess what the output is. So I'll go to the Eclipse and I'll write some program for you. So I'll go to the Eclipse, right? So this is my Eclipse. I'll create one class here. I'll name that class as primitive example. I'll create this main method as well. So I'll tick on that. I'll click on finish. Now, uh, I'll write some code here. Int x equal to 10. Int y equal to x. And y equal to 20. And I'll say sys out. I'll print the value of x. So I'll save it. Can you guess the output of this program? If you said 10, then it's good. But let's run this program. See the output. So see, we got the 10. So, but what actually happens inside the memory and why it prints the 10? So that's the difference between the coding and the understanding, right? So let's break it down. Okay. So let's break it down here. Let's see here. Now, you can see when we declare x equal to 10, right? Java stores this value directly x equal to 10 inside the stack memory, right? And when we write x equal to, when we write, sorry, y equal to x, when we write y equal to x, then this is a critical operation here, right? So Java copies the value. Java copies the value 10 into the variable y. So it's not copying the variable. It's not copying the memory location address. It's simply copying the value into the variable y. Okay. So y will be copied y, 10 will be copied into the variable y. The value, this operation is basically called value copy behavior. So this operation is basically called as a value copy behavior. You need to keep in mind this. So you guessed it right. The output was 10. Now let's move on to the next concept here. This output was 10, right? Now let's visualize this. What happens inside the memory? Inside the stack memory, you can see that x equal to 10 was saved. Then y equal to 10 was saved there. After that, we made y equal to 20. So the value of x will be 10 and then value of y would be 20. This is how the stack would be saved. So you can see I have a visual diagram over here. You can see that x is 10, right, inside the separate box, and y equal to 20, that is also inside the separate box. So both have a different memory location. right? Now, let's talk about non-primitive data type. Those are object reference data type. So let's quickly begin here with one of the example, and let's straight away jump on the concept now. So I'll go to the Eclipse here. I'll create one new class here, non-primitive example, right? And I'll click on finish, right? I'll also take the main method as well. So you can take the main method by writing main. Now, here we are going to demonstrate this non-primitive data type example. So I'll create a class here. I'll create a class student, right? In that student, I'll take a variable marks, member variable marks. Now I'll create the object of the student inside the main method. I'll say student, student s1 equal to new of student. Now I'll say s1 dot marks equal to 90. Now I'll create another object as well, right? Or let's say I create a reference only, or I'm not creating the object, I'll just create a reference. This student s2. Now in this student reference s2, I'm assigning the reference of s1. Now I'm saying s2 dot marks equal to 50, right? And I'll simply print out the marks of s1 and s2. Sys out uh, s1 marks s1 dot marks, and same thing for s2 as well. So I'll simply copy paste this line and replace it with s2 marks. So s2 and s2 dot marks. Can you guess what output we will see on the screen? Any guesses? Now let's run this program here. This I'll say run as a Java application here. Now see, it's printing s1 marks is equal to 50, s2 marks equal to 50. Now this is the key point here, that we have created the object s1, right? And Java creates the object, okay, inside the heap memory. So this object s1 is created inside the heap memory, and s1 is storing the reference, right, and not the object. So this s1 is storing the reference, not the object. Okay. Now you notice this line, student s2 equal to s1. We have written here student s2 equal to s1. Does this copy the object? No, it doesn't copy the object. It copies simply the reference. This is a huge difference. Most of the people get confused here. So you have to keep in mind, if I say this one student s2 equal to s1, It's not copying the object, it's just copying the reference. That's a huge difference. Okay, so now when we modify this marks, s2 dot marks equal to 50. So this, we are modifying the same object because both the references are pointing to the same object. So both S1 and S2, both S1 and S2 will print 50 because they are pointing to the same memory address of the heap memory address, right? If you understand, because they are pointing to the same object, okay, as the references are same here. So it's pointing to the same object, and if you are changing the value, that means it's we are changing the value of the object, right? So if you understand this, let's go to the if you understand this from a this interview point of view, X, now you would be ahead of the beginner level in Java, because we are just simply assigning the reference and both the references are pointing to the same object. Now let's quickly visualize this by a memory diagram here. So I'll go to the visual diagram. So x equal to 50, this was the output, both the object print the same output, 50 50. Now this is where the memory visualization of the non-primitive data type starts here. So we are going to compare here with stack versus a heap. Okay, so what actually stores in the stack? So stack stores the basically reference variables, right? So this is S1 is there and S2 is there present in the stack. These only the reference is there. But if we talk about the heap memory, so it's going to store the object. Okay, initially the marks value was 90 and then after the change we made it 50, right? So that's how the stack versus heap would look like. So it's basically you have S1 object, S2 object there. They both are pointing to the same. This is basically S1 and S2 are, sorry, S1 and S2 are references. Both are the references and both are pointing to the same object in the heap memory. So you have two references and one object. Once again, I repeat. So you have two references and one object. Now let's move to some of the another special case in Java. String special case. So strings are object, but these are immutable. So it's a very favorite interview question. That's why strings are immutable. Now let's go and check this one. Okay, I'll go to Eclipse and I'll write some code for the string example. Okay, so I'll click right click on my package. I'll click on new. I'll click on the class. So I'll say string example. String example. Right. And I'll take the main method. Okay. I'll write some of the code here. I'll say string a equal to hello. String b is assigned as a. I'll write then b equal to world. So if I try to print this, I'll try to print a. and I'll try to print B as well. I'll save it. Now, what do you think? What can be the output? We are not modifying this hello, right? So let's see what's the output. If I right click and run as a Java application here, so see, I get the output as hello, which is of the string object A and world of the string object B. Now that's the key point to be noted here, that we are not modifying this hello. We are not modifying this hello. We are creating a new object. We are creating the new object. That's why the strings are immutable. Even though we assign that B is assigned as A, we are not modifying this hello. We are creating the new object, right? That's why the string behave differently from other objects, and it's very common interview question, right? So why strings are immutable? So this is the clear explanation here. Now let's move further. So you can see inside the heap memory, the hello is created, a hello object is created here, and the world object is created here. Both are different. So strings are objects but immutable, right? So it's original hello, it's not change, right? Even though we try to assign that, uh, but it's still not change. So that's how the strings are immutable. You have to explain like this way in an interview. Now let's move further. Now we will be moving this with the array example here. Okay, so it's very important to know, uh, basically arrays are non-primitive data type. Okay, now let's quickly see the behavior of the arrays here. Okay, so basically the arrays are behaving like objects in Java. So now let's quickly move on to the example here, and let's see what the arrays behave like. So I'll go to the Eclipse and I'll say array example. I'll create one class array example, and I'll write this. I'll take on the main method as well and click on finish. Now I'll write few lines of code here. I'll declare one array, integer array, int square bracket arr1. I'll assign some values here. Let's say 1, 2, 3, 4. I'll close the curly brace and I'll declare another array, integer array arr2, and I'll assign the reference of this array 1 to the array 2. Okay, and I'll simply say arr of 2 is 99. Now can you guess the output if I want to print this out? arr of I want to print it out arr of 0, arr1 of 0. Okay, I'll save it. I'll run it. Can you guess the output? I'll run it for you. See, run as a Java application. Now see, The array ARR 1 of 0 is output is 99. But we haven't changed the value of array 1, right? This is how the array behaves. This is how the array behaves, just like an object. Okay. So we have copied the reference of array 1 into the array 2, and they both are pointing to the same memory location. So when we modify the array 2, the array 1 value also will change. So that you need to keep in mind. Okay. So that is very important concept from interview point of view. Now let's move further. So you can see the memory diagram visualization here of arrays. Arrays are basically non-primitive data types. You know this. Uh, Inside the stack memory, you can see that the array 1, array 2 have the same reference, and in the heap memory, both are pointing to the same location, right? So reference is copied, the same memory location. So that's why the both are pointing to the same memory location. Now move on question here. Now I'll go to my Eclipse and I'll create one class here. Sample example. I'll click on main method. Okay. I'll one create class here. I'll say class change. I'll give the name of the class as change. Okay. And inside this class, I'll create one method. Public static void change value. And inside this, I'll pass some of the arguments and num. Then I'll say num equal to 20. Okay. Now inside the main method, I'll create one variable. I'll create one variable int a equal to 5, and I'll simply call this method. Okay, as this is a static method, so I did not need to create the object for calling this method. So I'll simply say I'll call it by class name dot method name. So I'll simply say class name, that is change dot change value, this method, and I'll simply pass the value to this method. Okay, and I'll simply print the value of a inside main method, and the value of a. Okay, now let's quickly run this program. I am just basically passing this value a equal to 5 to this method change value, and let's see what this happens. I'll click right click run as Java application. I'll say okay. Now see what the output has came. Inside main method, okay, the value is 5. Now, but can you See, I was just expecting that the value should come out to be 20 because I have passed this value to this method change value and I've changed the value to 20. But it's not showing me 20. Why? Any guesses? Once again, I'll run for you. Why? So the reason is that basically you have this whenever you declare this variable int equal to 5, Java directly stores into the stack memory. Okay, and when you call this method, when the method call happens, Java always pass by value. Java always performs this pass by value. This means that Java copies the value of a and send it the copy to the method. So basically Java is going to copy this value and it will send a copy of the variable or the it will send to the copy into one copy of the variable into the method. This, okay, it does not send the original value. Okay, it sends the copy of the variable. So the copy of the variable is being passed here. Okay, and it's been and inside the main method, inside this change value method, you have num equal to 20. So Java creates a separate variable when we write num equal to 20. Okay, so we are changing only the local copy. We are changing here only the local copy is being changed here. Okay, so inside the method, when we say num equal to 20, so that is a local copy. But outside the method, a equal to 5, a equal to 5 there. This is basically the concept. That's why the value is 5. So Java clearly passes the value. It's basically Java clearly is passed by value even for the objects. So Java is clearly passed by value even for objects. So when passing the primitive, that is actual value is being copied. So the actual value has been copied. When passing the objects, the reference is copied, but still the it's passed by value. So that's very important. You have to note it down. Okay, so if this finally makes you clear about primitive and versus non-primitive data types, stack versus heap, and uh, array concepts here, some of the. So hit the like button, subscribe the channel. Thanks for watching this video. In the next video, we are going to deep dive into the one of the most important concept, that is typecasting. So uh, that's where the real Java begins. So here's a comparison table: primitive versus non-primitive. Primitive stores the actual value, non-primitive stores the reference. Memory stack: primitive stores the data in stack memory, non-primitive stores the data in heap memory. And the copy behavior of primitive data type is value copy, and non-primitive data type behavior is reference copy. Example of primitive data types is int char. Non-primitive data types is arrays, strings, object. So talking about mutability, so primitive data types are mutable. Non-primitive data types are depending upon the depends. Okay. So here's a summary slide. Final understanding is that primitive stores the actual value, object stores the references, arrays reference behavior, strings have immutable behavior, Java is always pass by value. So it's one of the summary slide here. So this is, if this finally made you understand primitive versus non-primitive data type. Uh, then hit the like button, subscribe the channel, and in the next video we are going to deep dive into the concept of typecasting. That's where the real Java begins. Thanks for watching this video. Thank you.